Okay, so looking at this relationship, we have some options, and now we can just kind of spitball. Basically, we could have maybe a relationship that looks like this. I hope you realize that would not fit our underlying assumptions about the way the world works. In other words, this would imply that there are negative returns to capital. In other words, the more machines we have, the lower our output is. That doesn't match anything that we're thinking about. And so basically the way to think about this is let's set up a form. We could have some constant here. I know that some of your brains are going to turn off here because of, right, math is a little scary. But basically we could think about this as y equals k to the alpha, where alpha is an exponent. And we can put other parameters in here, but basically this would be the case when alpha is less than 0. Now some of you may remember this. Y equals k to the negative 1. This would be less than 0, right? Anything to a negative exponent would be, you take that and you put it in the denominator. So y equals 1 over k would be this here, would be the same thing. In other words, as you increase capital, what happens to output? Holding the numerator constant and increasing the denominator is going to cause output to fall. Fair enough? Now, say we had negative 2. This would just be 1 over k squared, and so on. But regardless, any alpha less than 0 is going to give us a line that looks like this. You don't have to know that off the top of your head. You can trust me on that. You can do a little digging. But basically, y equals k to the alpha when alpha is less than 0 doesn't fit what we know about the world. And so we can now rule out some things. I'm just going to rule out things, an alpha less than 0. That's not going to make sense, right? That would mean that as we have more machines, we become less productive. Yeah, no. What's another option? Well, let's try alpha equal to 0. Now this one may hurt some other brains because k to the 0. Anybody remember? Maybe you remember, maybe you don't know what k to the 0 power is. But it turns out anything to the 0 power, doesn't matter how big or how small it is, anything to the 0 power is 1. And so what this would imply, if we have an alpha equals 0, what that would imply is that there is no relationship between capital and output. In other words, if we have 1 machine, we would have 1 unit of output. If we had 10 machines, 10 to the 0 is 1, we'd have 1 unit of output. If we had 1,000 machines, 1,000 to the 0 power is 1 unit of output. In other words, there would be no relationship. So we can also rule that out. Maybe I'll put the x over here. So what are some other options? Well, we could say, maybe let's try alpha greater than 1. Let's do that. So we ruled out an alpha less than 1, less than 0, and an alpha equal to 0. Maybe we try greater than 1. So let's try something. Let's say y equals k squared. What that's going to result in is a function that looks like this. In other words, now we get into the difficult thing, okay? So here would be the question. What would we think about machines? In other words, do we think that the first machine is going to increase productivity by more or less than the second machine? It's a little tricky, but maybe we can use some examples. Maybe we could think about, at least for me, right? I worked construction for a while. The first electric circular saw, zip saw, depending on worm drive saw, etc., right? Skill saw. The first one of those on a job site is going to have a big impact on productivity. People can go from using hand saws to using a skill saw. So that's going to have a positive impact on productivity. How about the second? Would we expect the second saw to have as much productivity as the first? Probably not. It'll still have a positive impact. Now two people can be using saws simultaneously, etc. But it won't have as much of an impact as the first one. How about the third? Well, eventually everybody has a skill saw. We have them lying all over the place. Basically, at that point, we might actually, on a job site, start seeing negative returns. They might actually make us less productive because we have so many of them lying around. That's one example. Maybe you could think about, you could think the same thing about hammers on a job site. The first hammer on a job site has a really big impact because people can stop trying to kick things with their toes, etc. They can swap back and forth. The second hammer has a positive impact. Now more than one person can be hammering at a time, but it isn't quite as big of an impact as the first hammer. Once we get out to 1,000 hammers, eventually our job site may well be littered with too many hammers. This is the same thing with cars within the family. So at least when I was growing up, we had one car within the family. That had a big impact on our productivity, on our ability to go to the grocery store or to the office or anywhere else. As a group, first car, big impact. Mom would drive Dad to the office and drop him off. I would walk to school. My sisters would walk to school. Cool. Eventually, we got a cheap second car. Little Yugo, made in Yugoslavia, piece of junk, but it ran, and it was really, really cheap. Second car in the family had a positive impact, but not as much as the first one. Now Mom and Dad could leave for the office or to do their errands whenever they wanted to without checking with the other person, and it had a positive impact, but not as much as the first. This is what we call diminishing marginal returns to capital. And I think eventually we see when my sister got to high school and got her driving license, eventually she got her own car. That third car made us as a family unit more productive. That third car had a positive impact, but a smaller impact than the first car or the second car. And the fourth car would have had a smaller impact than that. So let's think about whether this here, so that's actually what we're trying to do here. What we're trying to do is figure out the mathematical parameter for alpha that would fit our assumption about the world. We don't actually care about alpha. We want a model that explains the world, that fits our understanding of the world. So I hope you understand what we're doing here. So now the question is, does an alpha greater than 1 match our understanding of the world with diminishing marginal returns? I'll make a side note here quickly. I do not expect for the economy as a whole to hit diminishing returns. On a job site or in a family driveway, we can eventually get so much physical capital that it clogs things up. But we are so far away from that as an economy that we may not even need to think about it. So we're just going to look at positive but diminishing returns. So let's look at this function here. This, it turns out, I've just told you that fits with an alpha greater than 1. You don't have to know why that is. You can try out some stuff. Feel free. But the key here is, does this fit our understanding of diminishing returns? So I'm just going to basically have each length of the marker be 1 unit of capital. So this first unit of capital causes us to go from maybe 0 to here. So this here is the return from the first unit of capital. And now let's look at the second unit of capital. A little hard to see here. Maybe we'll go out and compare a little bit more. This is the return to the second unit of capital. Part of this, by the way, is an artifact of how I'm drawing this. It turns out that if I draw this carefully, this distance here would be greater than this distance here. In effect, we're getting a bigger impact on output from the second sewing machine in the household than we did out of the first sewing machine. Let's see if we can see that out here. Maybe it gets easier to see once we get further out. So this is the return to the second sewing machine. This is the return from the third one. Now it's getting bigger, and we go out further, it gets even bigger. An alpha greater than 1, it turns out, is in keeping with an assumption of increasing returns. That also doesn't fit with what we know about the world. Not because we don't like the value for alpha, but because that value for alpha doesn't fit our understanding of the world. So let's try another one. A straight line here, that would be in keeping with alpha equal to 1. Does that fit? Well, by definition, that would mean that the first unit of capital gets us this much output, and the next one gets us this much output, and the next one gets us the same amount of output, and same amount, and the same amount. This also doesn't fit our understanding of the world of diminishing marginal returns. This would be what we would call constant returns to capital. Each unit of capital, each machine, causes exactly the same increase in output. And that also doesn't fit with our understanding of the world. We have a pretty good understanding that, you think about this. I, this week, ended up getting a second PlayStation controller. Why? Well, because the left analog stick on my existing controller, I only have one of them, seemed to be sticking occasionally. I was a little worried. And so now I have a backup controller. Does that have as much impact as the first controller? Having two controllers? No. I'm only going to be using the backup controller either when a friend comes over to play or when my first one maybe loses battery life or eventually conks out. So it has a positive impact on my well-being and a positive impact on my ability to play video games. But it is not going to have the same amount. So it would neither be increasing returns nor constant returns. It certainly wouldn't be no returns, and it certainly wouldn't be negative. And so what we now need is something that fits with diminishing marginal returns. So what's left? We've ruled out alpha less than 0. We've ruled out alpha equal to 0. So I can actually combine these to be that we have ruled out alpha less than or equal to 0. We've ruled out an alpha greater than 0, and we've also ruled out alpha equal to 1. And so we can actually combine these two into say that we've ruled out an alpha greater than or equal to 1. So what's left? I'll grab a drink. What's left is an alpha that is in between 0 and 1. And the function that that's going to describe is going to look like this. Whoops. This is any alpha between 0 and 1 will have this shape. And we can now go back and look at whether this fits with diminishing marginal returns or not. Before I do that, let me just make a note that the textbook is going to put 1/2 in for alpha. Why would we do that? Well, if you think about those rinky-dink calculators I normally was giving you for the exams, even a simple dollar store calculator like that has a square root function. And k to the 1/2 fits with our square root function. In other words, that's what that is. This is the same thing as the square root of k. So that's one thing. It works on dollar store calculators. It also turns out that, guess what? 1/2 is in between 0 and 1. Now I can just note that in the real world, most empirical estimates, put alpha at around 1/3. We could talk about what that means. We could talk about why it's 1/3 instead of 2/3. But for our purposes here, the key is simply that it's between 0 and 1. Why? Because that fits our understanding of diminishing marginal returns. The textbook uses 1/2, not because it's true, but because it's easy. It's easy and it analytically fits our underlying assumptions. So now we can resume the fancy slides that I have to hopefully look through whether this fits our understanding of diminishing marginal returns.